Please welcome Maria Friedrich, ETH Zurich.
Hello, I'm Maria Friedrich, Entrepreneurship Manager at ETH Zurich. My role is to coach founders through the critical stage, from academia research to entrepreneurship, and to foster connections so they can learn from each other. I'm delighted to nominate today Unbound Potential, an ETH spin-off for the Falling Walls venture competition. Unbound Potential is developing the only truly scalable battery to fully enable the transition of energy. Their breakthrough, a membraneless flow battery built from abundant and safe materials with minimal manufacturing needs. This novel approach enables unprecedented scalability and sustainability. Unbound Potential is breaking the wall of energy storage, unlocking a net zero future. That's why I believe they deserve to be recognized as the Falling Walls Science Breakthrough of the Year in the Science Startup category.
Breaking the wall of unsustainable battery energy storage. David Taylor, Unbound Potential.
Hi, I'm David, the CEO and the co-founder at Unbound Potential. Having just raised a total of 14 million pre-seed funding, we're currently one of Europe's best-performing deep tech early-stage startups. At Unbound Potential, we're building the fastest scalable battery technology, a core enabler for the global energy transition. Now, let's have a look at the challenge. The climate change, the AI revolution, and massive electrification are all driving an unprecedented hunger for electrical energy. In 15 years from now, the European Union, the energy consumption in the European Union will almost double. Now, where will all this energy come from? Solar power is the fastest, scalable, and most sustainable way to produce electrical energy. It's cheap, scalable, and abundant, but not available 24/7. In order to make it really reliable, we need massive energy storage. The International Energy Agency predicts that by 2040, we will need 3 times more batteries than the world can even theoretically produce. The gray line you see here shows the predicted production capacity for lithium-ion cells, which will double by 2040, and it falls short by far. In that scenario, it's not about cost or efficiency, it's about availability. Which technology can really scale fast enough? Now, if you look at traditional batteries like lithium-ion or sodium-ion batteries, they're fundamentally limited by their cell architecture. The energy storage material is integrated into the cell, which requires micro-precision, tedious manufacturing in clean and dry rooms, which makes gigafactories enormously expensive and hard to scale. Now compare that to tank-based flow batteries, where the energy is stored in 2 liquids, the electrolytes shown in orange and blue here, that are stored externally in tanks and are pumped through the cells at the site of use. So all the tedious integration steps are simply omitted. Now, if we look at the cost of a factory producing these energy storage liquids, is 5 times cheaper than a gigafactory and has 15 times the capacity output. That means flow batteries scale 60 times better than lithium-ion batteries in terms of manufacturing cost. Now, there is one big bottleneck, and this is the central power-producing component, the cell stack. It's a multi-layered, complex assembly which relies on a fragile membrane, which is shown in red here, and it's required to keep the 2 energy storage liquids, the orange and the blue one, separated. And it makes a large-scale and high-speed production almost impossible. At Unbound Potential, we're breaking this wall. We've developed a completely new type of flow battery that does not require a membrane. By this, we can drastically reduce the number of components and sealing phases. We do this by using 2 immiscible electrolytes. They behave like water and oil that allows us to completely disrupt the membrane. And this allows us to build our cell stacks out of only 2 injection molded components that are directly compatible with large-scale manufacturing assets that already exist. So we don't even have to make the factory. And that's also our business model. Of course, we want to sell storage systems to our customers, but we do not want to build the factories. We want to partner with strategic contract manufacturers from the chemical industry for making the liquids and automotive suppliers for making the hardware. And this model is validated by key players already having the largest growing energy needs. Amazon for electrifying its truck fleets, Econi, one of Europe's largest power producers, for selling solar power when it's really needed, and FlexBase currently building one of Europe's largest AI data centers where batteries will provide peak shaved and continuous energy. Now going from a whiteboard idea to 14 million in pre-seed funding, 600 square meters of space with full-blown chemistry labs, a prototype workshop, test facility, really requires a stellar founding team. Us founders, we're from the University of Zurich and different departments at ETH Zurich, spanning from electrochemistry, material science, electrical and mechanical engineering to economics and finance. We're supported by world-class industry leaders who guide our decisions, among them Carlos Hertel, the former CEO of GE Germany, and Bettina Jarrière on the board of several international energy companies. At Unbound Potential, we developed the only battery architecture that scales fast enough to really enable a truly sustainable future. And you need this because your ChatGPT outputs, but also your cars and your home, need reliable, clean electricity. Now, let's unbound our potential and power the future together.
Thank you. Perfect timing. Okay. Ready for the questions? You see, it's very fast, so we need to be fast. Please, Detlef. The microphone, please.
Great presentation. If you find the solution for all the chemicals membrane, how mobile is this battery?
This battery is designed for stationary applications.
Okay.
Iris, right?
How does your levelized cost of energy compare to lithium-ion batteries?
We will be cost competitive and even beat lithium-ion batteries at scale. We designed our components to really scale, follow economies of at scale. So right now we're looking at costs below $50 per kilowatt hour.
Yeah, please. Yeah.
Is this still vanadium-based? Do you need any critical material in your technology?
No, the energy storage materials are based on organic energy molecules that can be synthesized in chemical factories as we have them in Basel and Mannheim.
Stefan first.
How does the economics look at the full cycle of it if you really scale the stacks, and how does it compare to other solutions?
We think it looks really amazing. So we have data from one of the potential early stage customers, FlexBase. They're building a 1.6 gigawatt hour flow battery in Laufenburg at the Swiss-German border. And they have real big issues even sourcing the components for such a big storage plant from reasonable suppliers within Europe. So our technology could be not just a competitive one, but also one of the only ones that actually enable such projects at that scale. Yeah, absolutely. So using chemicals that can be commoditized and be made by large chemical industry, also oil and gas players, and injection molded parts that actually are the hardware, and using workflows that are standardized in automotive supply industry, we can actually hit the cost targets.
Great. Next question, please.
Since those are two immiscible electrolytes, how do you generate electricity without the membrane?
Thank you.
We use a trick. Of course, we need electrolytes that feature the same ion conductivity for the system to work as if there was a membrane, and a special energy storage material that stays separated in these two solvent phases without having the cross-contamination issue. So there are some tricks we play, but we basically shift the complexity from the membrane, which is a mechanical part, to the liquids, which is a really scalable part.
Yeah. Next question was Cyriac, right?
Great idea, great concept. Question, how do you want to compete against the massive players like Tesla?
Yeah, I think they really face this one big issue, which I mentioned before. They need gigafactories in order to scale their production. And we already know now, by looking at the pipeline of gigafactories that's planned to build, that they will not be able to make enough of them. So, and we use existing assets that will have a free production capacity to just produce much faster in a much more scalable way.
Next one. Thank you.
Maybe a follow-on question on that. How will you compete against China? Because I think the price is a very important thing.
Yeah, basically it's the same question, because most of the battery, at least the significant part of the supply chain of all the battery solutions we can buy now is in China. So we only compete against China, and yeah, we will compete against them by using massive infrastructure and production assets that are already available in Europe, and people are looking to pivot and switch and have new targets and target markets. So automotive industry, for example, are really struggling to find new things to make, and this could be the next big thing they should be actually making.
I'm sorry, Mali, we won't be able to take your question, but thank you so much for this great Q&A. I love the rhythm. You felt that? We're getting into the mood. Thank you so much. Please.